Hey everyone, this is just going to be a quick video where I talk about how we can find an exponential equation given 2 points. So as we've seen, the form of an exponential equation that we are talking about is this one right here. F of x equals a times b to the x. And so as we talked about in class, a is giving us our initial value, and it tells us about our y-intercept graphically. And then b tells us about how fast our function is growing or how fast it's shrinking. And we would call b the growth rate or the growth factor. So if I'm going to find an exponential equation, what I need to do is find a number that I can have for a and a number that I can have for b. And so as it turns out, if I have 2 points that I know are on the graph, this is something that I can do. All right, so for our example today, I'm going to consider 2 points. Okay, so I'm going to say this point 2 comma 45, I want that to be on my exponential function, and this point 5 comma 1215. And so I want both of these to be points of my exponential function, and what this means is if I have an input of 2, I should have an output of 45, and if I have an input of 5, I should have an output of 1215. Okay, so I think what's going to help us out a lot here is thinking about this as inputs and outputs. Okay, so if we go back to our notation, so if I come over here and think about the notation that I'm using for functions, I know that this x right here is an input and f of x is my output. So what I'm going to do is anytime I see an x here, this is going to be my input, right? So these will be inputs. And then over here, f of x as itself will be my output. Okay, so let's go ahead and take our first point. So I'm going to do it in red and see what information we can get from that. So f of x is an output. So that means 45 is equal to a times b, and then my input is going to be 2. Okay, so the information that I get from my first point is this here. When I have an input of 2, I have an output of 45, and I'm still not sure what a and b are, but I do know that whatever they are, they have to satisfy this relationship. Okay, so next, if I go to my blue over here, what I see is, well, if I have an output of 1215, that had to come from an input of 5, so I should have this a times b to the 5th. Okay, so with these two together, I need to find an a and a b so that if I plug them into this equation, it's true, and an a and a b so that if I plug them into this equation, it's true. Okay, so what I'm going to do is I'm going to take both of these equations and I'm going to somehow put them together. So what we've seen is, if I'm going to put these two equations together, I could add them, I could subtract them, I could multiply them, I could divide them, or there are other things I could do. But I think what's going to be most helpful for us is if we try to divide them. So when I go around and I look, I'm going to try to find my biggest exponent on b. And so you can do this other ways, but what I'm going to show us today is I'm going to always look for the biggest exponent that's on b, and I'm going to write that out. So I have this ab to the 5th is equal to 1215. And what I want to do is divide by the other equation. So on the left-hand side, what I want to do is I want to divide by the terms that have a's and b's in them. And on the other side, I want to divide by this number. Okay, so what I know is these two things in the context of this problem are the same. So on one side, if I put this, and on the other side I put this, we're saying that those are the same. So we're really dividing by the same thing. Okay, so what I'm going to do on my left-hand side of this equation, I'm going to divide by ab squared. And on the right side of this equation, I'm going to divide by 45. Okay, so when we look, we think about our exponent rules. And what's going to happen is this a and this a will cancel. And then I'm left with b to the 5th over b squared. Okay, so notice I have the same base. So when I reduce this, I'm going to take 5 minus 2. And on the left-hand side, I end up with b cubed. And over here, if I do 1,215 divided by 45, you can plug that into a calculator, you could do it out, and what you end up getting is 27. All right, so I get this new equation, b cubed equals 27. So this looks something that's very manageable to me. Right, so I have b cubed is 27. I feel like this is something that I could solve. So when we get more complicated things, in general, the way that you want to solve this is you want to do it by taking a root. Okay, so notice how my exponent is a 3 here. So what I'm going to do is take a cube root. Now, when we get higher roots, when we get like 4th roots or 5th roots, it's often going to be helpful for us to think about raising it to an exponent. So what I'm going to do is I'm going to take the left-hand side, and I'm not going to write out the cube root, but I'm going to raise it to the 1/3 power. Okay, and so on the other side, what I can do is raise this other side to the 1/3 power. And so what we end up getting here is that, well, 3 times 1/3 is 1. And so what we get is b on the left. And 27 to the 1/3 power, turns out that that is 3. Right, so if you're wondering how I did that, you can just think about the cube root of 27, or if you were to plug this into Desmos, you would get 3. Right, so what I've done is I have figured out one of my values. So I needed an a and a b, and over here you can see that we've got our b. So I'm going to come back and I'm going to take this b and I'm going to plug it into one of my equations. And so I could pick either one of these, it doesn't matter which one. This one I'm going to choose, it just has, this one has a smaller exponent, so I think it'll be easier to work with, but we could do the same thing with the blue equation. I'm going to take this and I'm going to plug in b equals 3 back into this right here. Okay, so what we get is 45 is equal to a times 3 squared. Okay, so 3 squared is 9, so I get 45 is equal to a times 9. And then if I divide both sides by 9, what I get is a is equal to 45 over 9, which is 5. Okay, so I get here a equals 5 and b equals 3. So just to finish this off, what I'm going to do is I put these together, and so what I get is f of x is equal to a, which is 5, times b, which is 3, to the x power. And so what we have is, here is an exponential equation, f of x, and it passes through the point 245 and 5, 1,215. Right, so this is a method for finding an exponential equation given any 2 points that are on that graph. Right, so I hope this helps. I'll see you next time.